Alright, this is our last section of Unit 3, so we're going to learn how to solve systems by using matrices. We are going to play a little bit on the calculator for today, so please go ahead and take out your calculators or have it accessible, but we won't get to it until the end of the notes. Alright, so matrices are a rectangular array of numbers written within brackets. It's usually named by a capital letter. So if we look at this first one, this one would be called matrix A. Okay, so this is matrix A. And then matrix A is a 2 by 3 matrix. So the way we name these, we name them by their size. It goes columns, then rows. So this, I said that backwards. It goes rows by columns. So there's 2 rows and 3 columns. So this is a 2 by 3 matrix. Okay, so then we're going to have the matrix element. So the matrix element is where we can identify where things are in the matrix. So like for instance, this one is B11 because it's in the first row, first column. This is B12 because it's in the first row, second column. And then it continues like this. This is B21 because it's in the second row, first column. B22, second row, second column. B31, third row, first column. B32, third row, second column. Okay, so this allows us to pinpoint or identify where numbers are in the matrix. So then we have these things called row operations. So it's an augmented matrix, any of the following. On an augmented matrix, we can do any of the following. So we're allowed to switch 2 rows. We can multiply a row by a constant. We can add 1 row to another row. Okay, so these are all legal moves to solve a matrix, ultimately. So again, we're allowed to flip-flop rows at any time. Columns do not ever move, just rows. Everything has to do with row operations. Okay, we can multiply a row by a constant, we can add a row to another row, we can divide a row by something, so on and so forth. So looking at this first one, we just want to identify what numbers are located in these positions. Okay, so this first one is A12, so this is row, then column. So what is in the first row, second column? First row, second column is the number 5. Okay, this is row 3, column 4. Row 3, column 4 is a 0. This is row 2, column 4. Row 2, column 4 is a 6. This is row 4, column 3. Well, I don't have a 4th row, so this is not a position in this matrix. Alright, so now let's go ahead and understand, well, what is a matrix? What is it representing? Why would we use this? What is it for? So again, we use this with systems. So this whole unit we've been working on systems. We've done 2 variable systems, and then the last lesson you learned about 3 variable systems, which are a lot more complicated. Okay, so this is what it represents. So how you set up a matrix is you're just dropping the x, y, z's, the pluses. You still keep in negatives because it's a negative number, and the equal sign. So this coefficient on this x, 2, is located right here. This coefficient on this y is right here, and then this answer is 9. So this bar is like the equal sign. Okay, so this side is answers, this side are the coefficients in front of your variables. We just do need to be careful that x's are together, y's are together. So these are my x coefficients, my y coefficients. Okay, so hopefully that makes sense how I get this to this or this to this. Alright, let's go to the next page. Okay, so the beginning of these notes are going to be really simple until we start solving. Solving's where it gets a lot more complex. Okay, so like these first ones, we just want to write what the matrix represents. Okay, so this is my system. So this is going to be a 2 by 3 matrix. There's going to be 2 rows, and then there's 3 columns. So that's what we're going to draw. You must use brackets I've had students who just don't use the brackets at all. I can't follow that. You need to put in brackets. So this is going to go a -4, a -2, a 7, a 3. Be careful, there's an imaginary 1 there, -5, and we put the bar representing that these are my answers. Okay, so that's what this looks like. Go ahead and do this one by yourself. The thing that we need to be careful about on this is not all of these are in standard form. This one is not in standard form. And if you have a missing variable, then it's a 0. Okay, so go ahead, pause, give this one a shot. Alright, so this one I need to put in standard form. So I'm going to do 2x, I'm going to add over that y, and it's going to equal 7. So now we're in standard form. Now I can go ahead and write this matrix. So this matrix is a 3 by 4. There's going to be 3 rows, 4 columns, because we have an x, y, z answer. So this one's going to go 4, -1, 2, 1. Next row, on the x, there's no x, so there's a 0. Then a 1, a 5, a 20. Okay, and then this one looking here, x is 2, y is 1. There's no z on this one, so we need a 0, and 7. Okay, so hopefully you guys understand how to jump from here to here or backwards. So that's what we're going to do now. Now we're going to go backwards. We're going to rewrite these back into actual equations. Okay, so this is a system. Systems use that little weird bracket. I don't know what it's called. Okay, so this would be your x's, this would be your y's, this would be your answers. So this would be a 2x. Technically plus 0y, we do not need to put plus 0y, equals 6. This next one would be a 5x minus a 2y equals 1. Alright, go ahead, write this one for me, pause the video, give that one a shot, check it when you're done. Okay, this one should be 3 equations with 3 variables. So this would be an x plus 3y minus z equals 2. Next one would give me an x. There's no y, so do not put plus 0y. And then there's a plus a 2z equals 8. This one there's no x, so I'm starting with y. 2y minus z equals 1. Alright. Okay, so hopefully you guys understand matrices are systems. They're just a different way to write the system without all the variables. So now we're going to learn how to solve a matrix. Okay, so when we solve a matrix, we want to get it in reduced row echelon form. Okay, so what is reduced row echelon form? So the way I kind of remember this is that you have ones going diagonal and everything else needs to be zeros. Ones going diagonal, everything else needs to be zeros. Okay, what we really want to talk about, so again this is called reduced row echelon form. So I will ask you, reduced row echelon form this matrice. Okay, so the whole purpose of doing this and putting it into this form is because now it shows you what your answers are. We've solved for our answers. And let me explain. So if you look at this first one, this spot right here would be an x, this spot would be a y. So this is saying 1x plus 0 y's equals a, whatever the number is, right? So really this is just saying x equals a. Next one, this would be 0x, don't need that. 1y is just y, so y equals b, whatever b is. So I've solved for my variables when it's in this form. Again, so this would say x equals a, y equals b, and z equals c, because there's no other variables, so you solved for these variables. Alright, so hopefully with that understanding we can answer this next one. So explain the meaning of this matrix. So again, this would be x plus 0y plus 0z equals 4. So what am I really saying? I'm just saying x equals 4. This one's in the y position. There's no other variables, so there's 1y, so y equals -1. And then this last one right here, that one is saying z equals 3. So my answer to this system would be 4, -1, 3. Okay, so far, hopefully super easy and you're understanding. Because now I'm actually going to show you how to get this into reduced row echelon form. All right, next page. All right, so here's our row operations. So these are the legal operations we could do at any time in solving our matrix. Okay, so we're allowed to switch any two rows. So I could flip-flop and put them in a different order. I'm allowed to multiply a row by a constant. I'm allowed to add one row to another row. And I'm allowed to combine any of these operations together. And that's really what we're doing. We're really combining these operations to get it in the form I want. So this is the only one that's in your notes. I'm going to add extra ones because obviously one is not enough to understand how this really works. Really, this is like a huge trial and error. And like obviously like anything, the more you practice it, the easier it is to like identify what kind of operation you need to do to the row. So I'll go ahead and explain this first one really slowly and what's happening, and I'll do all the work. And then in the future ones, you're able to do most of this work in your head as long as you understand what you're doing. And I will talk through that process. Okay, so step 1 to solving a matrix. Put this into a matrix. So this matrix will be a 2 by 3. So I'm going to have a 9, a -2, and a 5. Next one's going to go 3, 7, 17. Like so. This one's actually probably my least favorite example. This one's harder. I would say this one's harder than what I try to give you. I try to give you a more simple one, but we'll go through this and then we'll do some other ones, so don't worry. Okay, so the first things first. Normally, except on this one, which is why it's a crappy example, but normally your first goal is to get this number right here to be a 1. Okay, so you kind of work by columns. So we work by columns. So normally we would go, I want this to be a 1. Honestly, there's no easy way to get this to be a 1. I'm not seeing any easy way to get this to be a 1. Normally, or like when I give you a nice one, like maybe all of these are divisible by 9 or something, so then you could just go through and divide all of this by 9. In this case, not so much. So again, not my favorite example. We'll do better ones. So I can't really figure out a way to get this to be a 1. So I'm actually going to move to this. So it's supposed to go 1, 0, and then 0, 1. So maybe I could figure out a way to get this to be a 0. And I do see a way I can make this become a 0. So again, we're allowed to multiply by constants and we're allowed to add rows together. That's what you're going to mostly do when solving a matrix. So I notice if I multiply this guy by -3 and I add these rows together, that will give me 0 because -3 times 3 gives me -9. -9 plus 9 is a 0. So I could get a 0 here. So this is how I do my, like you have to, what's it called? Like you have to label, I'll show you. You have to label what your operations are so I can follow your operations. And so you can follow your operations and go back and see if you made a mistake somewhere. Okay, so what I'm going to do is I'm going to do -3 times row 2. And then I'm going to add it to row 1. Okay, and then we put this arrow, and this is saying, and then I'm going to replace. So whatever this answer is, where do I want to replace which row? And I want to replace row 2 because I'm going to get a 0, and I want the 0 right here. So I'm going to replace row 2. Again, hopefully you guys are understanding this. Well, you're probably not yet. So I'm going to go ahead and write my next one. So I'm replacing row 2. So I'm not even messing with row 1. I'm not replacing row 1. Row 1 is remaining the same. So we can just copy that back down. Row 2 is the one that's going to change off of this operation. I'm going to go ahead and do the operation off to the side. Normally I would just do this in my head and get my new row, but I want to show you my process, what I'm thinking. Okay, so we want to do -3 times row 2. Everybody good with that? So I'm going to do -3 times row 2 plus row 1. So row 1's going to stay the same. I'm just going to go write this one down. So row 1 will stay the same. And I'm going to end up adding these rows together. And row 2 is going to be multiplied by -3. So I'm going to look at row 2 and I'm going to multiply all these numbers by -3. So -3 times 3 gives me -9. This one is going to be -3 times 7 is -21. And then right here, -3 times 17 is -51. Okay, so now we're going to go ahead and add these together. So we're going to add those together. I'm going to get a 0. I'm going to get a -23 and a -46. Okay, this is my new row 2 because I'm replacing row 2 with this operation. So now this guy is now going to be my new row 2. So now I have a, and you know what, let's keep that in red so we can see where that went. So I have a 0, -23, -46. Okay, so I still haven't messed with row 1, so still row 1 is not nice. It's not pretty. I can't get this to be a 1 easy unless we have fractions, and I know most of you guys don't want to deal with fractions. Okay, so the next thing is, so this is supposed to go 1, 0, and then this one's supposed to go 0, 1. So is there a way to get this -23 to be a 1? And hopefully you guys can see what I can do to this entire row to get it to be a 1. So I notice that this is divisible by -23, and so is this number. This is also divisible by -23. So now my row operation is I'm just going to take my row 2, and I'm going to divide it by -23, and I'm going to replace my row 2. So again, row 1 is not changing, so we're just going to copy it down. Okay, and then I'm going to go to row 2. Hopefully we can just do this in our head. I hope we're to a point. I can do this in my head. So I'm just going to do 0 divided by -23 is 0. -23 divided by -23 would give me 1. And -46 divided by -23 would give me a positive 2. Alright. Let's go, I guess I'll do my row operation and then we'll move up here. Okay, so we're making progress. We're getting there. We have 2 correct numbers in its spot. So again, still no easy way to get this to be 1, so my next goal is to get this guy to be 0. So the easiest way to do this, and normally like we work by columns, you get it to be a 1 and then you manipulate that 1 to get everything else to be 0 in the column. So that's what we're going to do now. So I have this to be my 1, and I want to get this to be a 0. Okay, so I'm going to somehow manipulate this 1, so when I add it to this guy, I get a 0. So if I multiply this 1 by 2, and then I add it to this row, this will become a 0. So that's what we're going to do. So I'm going to do 2 times my row 2 plus my row 1, and then which row do I want to replace? Where do I want that 0 to end up? I want it to end up in row 1, so I'm going to replace my row 1. Alright, hopefully that makes sense. So again, we're going to add that row 1, which is 9, -2, and 5. This row 2, I'm going to multiply the whole thing by 2, so I'm going to get 0 times 2 is 0. I'm going to get 1 times 2 is 2. And then I'm going to get 2 times 2 is 4. And then I am adding these together. So I'm going to get 0 plus 9 is 9. Negative 2 plus 2 is 0. 4 plus 5 is 9. So this is my new row 1. This is my new row 1. Okay, hopefully we understand that. Okay, so row 2 didn't change. Row 2 is still the same, so I still have 0, 1, and that 2. Row 1, though, is now this guy. So it is 9, 0, 9. Okay, I'm super close to being finished. I'm almost there. It's supposed to go 1, 0, 0, 1. I just need this guy to now be a 1. This is now an easy one because I can divide this whole row by 9, and if I divide this whole row by 9, that will be a 1, and nothing else will change. So let's go ahead and do that. So I'm going to do row 1 divided by 9, and I'm replacing row 1. Right? Row 2 is already solved for because I have a 0 and a 1, so this is saying y equals 2. It's already solved. So that's going to stay the same. Row 1 is the one that is changing. So I'm going to divide it by 9. 9 divided by 9 is 1. 0 divided by 9 is 0. And 9 divided by 9 is 1. So we solved this. This is in row reduced echelon form. And yes, I like you to write this at the end of solving a proof. I proved it. This is in row reduced echelon form. And what is my answer? My answer would be 1, 2. X is 1, Y is 2. Alright, I'm sure you're probably having like a little bit of a heart attack right now. Don't worry. It will get easier if you practice it. I don't test you too much on this. You guys will be okay. But I will show you guys how to do this on the calculator so the calculator could do all that math for you. So just so you guys are aware, this would be something that could show up on a calculator test. So if we have those calculators available, let's go ahead and bust those out real quick, and I'll explain to you how to do this. Let me get my calculator out. Okay, here's my calculator. Oh, I was playing with it. You can see that. So let's go ahead and start by clearing our calculators. Remember that is second, plus sign, memory. And then it's 7, reset. And then it's 1, all RAM. And then it's 2, reset. Until it says RAM cleared, we're good. Okay, so again, remember that's just wiping everything and making sure we're back to a clear, clean calculator. If we were doing regressions, you would have to right now go turn on diagnostics. For this type of question, we don't need diagnostics. We don't need that R value, that correlation coefficient. So for this, you guys are good not to turn on diagnostics. Alright, so this is how you do it. And they have it written down in the notebook. Hopefully you guys can follow that. So we'll go ahead and do this example in the notebook. This one right over here that we can't really see because my screen. That guy right there. So we're going to go ahead and do that one. So what you're going to do is you're going to hit second and then X to the -1 because it says matrix on top. So we're going to go second matrix. And this will pop up. So first is just the names of the matrix. The next one is the math that we can do on the matrix, and that's where we will do row reduced echelon form. And then the third one is to edit the matrix. So we need to edit the matrix so it knows what's the values. So go ahead, we'll edit A, press enter. Okay, we have to tell the calculator what size is my matrix. So again, it goes rows, then columns. So this has 1, 2, 3 rows and 1, 2, 3, 4 columns. So this is a 3 by 4. So you're going to put 3 by 4. And it will automatically give you that 3 by 4. Okay, it's going to fill in per row. So you guys can just go put in the number, press enter. So this number right here would be a 1. There's an imaginary 1 there. So 1, enter. Then I have a 4. Then I have a 6, and then I have my answer of 21. Okay, next row I have 2. I have a negative 2. I have a 1 and a 4. Last one, I'm missing an A value, so it's a 0. So we'll move over. And then I have a negative 8. Then I have a 1. And then I have a negative 1. Okay, so now everything is in my matrix. We need to go back to our home screen. So again, that's second quit or second mode. These two buttons right next to each other will take you back home. Alright, now I want to use the calculator to calculate that row reduced row echelon form. So we're going to go back into matrix. So we're going to go second matrix. Now we're going to go to math because we're going to calculate some math. And then we're going to scroll down until we see RREF. So I think it's letter B, or it might be, yeah, B. So we want RREF. We want the reduced row echelon form. Okay, go ahead, press enter. So now it just puts it on our screen. So now we have to tell it, okay, which matrices do we want you to do this reduced row echelon form on? So now you're going to hit second x to the negative 1. And now you're just going to choose names. We want it to go to this matrix A, the one that has a 3 by 4 in it, so press enter. So then it will put matrix A in here. Close your parenthesis and press enter. And voila, it does a row reduced echelon form for you. Okay, let's go ahead and practice that one more time. Let's do the one that we just solved by hand, example 5. Let's put that one in here. Okay, so let's do it again. Let's go second matrix. We want to go to edit. We can just put it in a new spot. So instead of A, let's edit B. Let's put it in B. Just remember where you put it. Okay, so example 5 was a 2 by 3. So 2 rows by 3 columns. Okay, and then we had 9, negative 2, 5. And then we had 3, 7, 17. Okay, perfect. Okay, let's get out of here, go back to our home screen. Second quit. Okay, same process. We're going to go second matrix. We want to go to math. Scroll down to RREF, B, press enter. Okay, now we have to tell it which matrix we want it to do this to. So we're going to go second matrix again. And this time I want it to be B because we put it in B. Close the parenthesis, press enter. And that's our answer. We got 1, 2, and they got 1, 2, so we did it correct. So this is a good way to check if you ended up doing your matrices correct. All right, so we're going to practice a few more by hand. There we go. Okay, so if you guys have a piece of paper somewhere, we're going to do these just on a piece of paper. Or if you have like space in your notebook somewhere, I would put this into your, like if you could staple this into your math notebook or something so you have this for reference. Like this will be really important. You want to have some more examples, most definitely. Okay, so this is from our notes today. This was 3A, so it was just one of the ones that we just rewrote. Like it was just one of the ones on the one page where we rewrote. So we're just going to actually solve this now. Okay, and this one's a much better example of like what types I will give you, like the easier ones, I guess. Okay, so again, it's supposed to go 1, 0, 0, 1. Oh, I don't have a, yeah, I do. Where's my pen? Oh, That's weird. It's showing as a whatever. Okay. So, oh, there it is. So we want this to become a 1 somehow. So we're thinking about, okay, how could I make this become a 1? And I look, I have a 2, a 0, and a 6. So this one's a nice one because there's a fairly simple way to get this to become a 1. And the way I can do it is I could take this whole row and divide it by 2 because all of this is divisible by 2, and then I get this to be a 1. So that would be my first step. So I'm going to take row 1, I'm going to divide it by 2, and I'm going to replace row 1. Okay. I'm not going to do the math on the side. We're going to do our math in our head, so hopefully we can follow along. Row 2 is staying the same. So you can just copy it down. It's not changing at all. Row 1 is the one that is changing, so I'll do it in a different color. That's the one I'm changing. So I'm going to do 2 divided by 2 is 1. 0 divided by 2 is 0. 6 divided by 2 is 3. Okay, and I hope you guys also notice this whole row is solved, so I already solved for x. X equals 3. Alright, so now I have this to be a 1. Now you work by columns. So your next goal is, okay, so how do I get this 5 to become a 0? And you utilize the 1 to make this happen. You manipulate your 1 to make this happen. Okay, so I need 1 to be a -5. How do I get 1 to be a -5? Well, I multiply it by -5. So I do -5 times my row 1. I'm going to add it to row 2, and I'm going to replace row 2, because this is where I want the 0. Alright, let's write it out. So now row 2 is changing, row 1 is the same. So just copy row 1 back down. Okay, so row 2 is going to change. So I'm going to do, this whole row is going to be multiplied by -5, and then I'm going to add it to row 2. So I'm going to do -5 times 1 is -5, plus 5 is 0. Put a 0. Next one, -5 times 0 is 0. 0 plus -2 is -2. 5 times, or -5 times 3 is -15. -15 plus 1 would give me a -14. Like so. Alright, looking good. So I've solved this column. Now we want to go over to this one and solve this guy. I hope you guys are seeing how easy, or I hope you're starting to identify what you could do. So I need this guy right here to become a 1. So I noticed this entire row could be divided by -2, and that will give me a 1 here. So that's what I'm going to do. So I'm going to do row 2 divided by -2, and it's replacing row 2. Remember, we don't want to replace row 1 anymore. Row 1's solved. So we don't want to replace that. Okay, so I'm going to come down here. Row 1 stays the same. 1, 0, 3. Row 2 is the one that will be changing, and I'm dividing everything by -2. So 0 divided by -2 is 0. -2 divided by -2 is 1. And -14 divided by -2 would give me a +7. So my answer to this, so it's solved, x equals 3, y equals 7. So my answer would be 3, 7. Hopefully this one was a little bit easier to understand than the one that we did in our notes. This one was definitely more simple and more standard to the procedure. Alright, we're going to go ahead and try this guy. Okay, so this one is written as equations, as a system of equations. So step 1 for this guy is write it as a matrix. So I'm going to get 4, 3, -16. I'm going to get -1, 1, 4. This one's going to do probably some more steps. I like to do multiple steps in one, but I understand how that could probably be confusing for you guys, so I'll try to just do one step at a time for the most part. Okay, so step 1. We want this guy to be a 1. Well, I don't see a simple way to do that by dividing. So like normally when we get it to be 1s, normally we could divide, that's like a standard thing to look for, I guess you could say. 4, 3, negative 16, they're not all divisible by 4. That's going to give me fractions, not my ideal situation. Okay, but what I do notice is this row has a negative 1 in that first spot. And you're allowed to switch rows at any time. So I'm going to go ahead and switch these 2 rows because then I get my 1 in my spot. And at the same time, I'm going to change this row to be negative. So I'm going to do negative row 2 is going to swap, so that's how I do swap, with row 1. Okay, so negative row 2, so I'm going to make all of these the opposite sign, and I'm going to swap the positions. Okay, so now this is going to get a positive 1, this will be a negative 1, this will be a negative 4. Okay, and then this row just moves down. 4, 3, negative 16. So I technically did 2 different things at once. Hopefully that was an easy enough 2 things that I didn't confuse anyone. Okay, so now I have my 1 in my spot. Perfect, that's your first goal. Now you want to get everything below it to be zeros. So I want to use this 1 to manipulate this to become a 0. So again, your standard way of doing this is you're just going to multiply this by negative 4, add it to this row, and then I'll get a 0. So I'm going to do negative 4 times row 1 plus row 2, and I want to replace row 2 because I want my 0 in row 2. Alright, so row 1 is not changing, so you're allowed to just copy it down. Not going to change. But row 2 will be changing. I'll do it in a different color. So I'm going to go to row 1. I'm going to multiply everything by negative 4 and add it. So I'm going to do 1 times negative 4 is negative 4 plus 4 is 0. So now I put a 0 here. Negative 4 times negative 1 is positive 4. 4 plus 3 is 7. Negative 4 times negative 4 is positive 16. 16 plus negative 16 is going to give me that 0. Okay, so hopefully so far so good. So now I've accomplished this. I have a 1 and I have a 0. Okay, so now we go to the next row. So your next goal is to get the 1 or the next column. You want to get the 1. So I need this 7 to become a 1. Hopefully we see how easy this one is. I can divide this whole row by 7 and that will become a 1. So that's what I'm going to do. I'm going to do row 2 divided by 7. And it's going to replace row 2. So again, row 1's not changing. I'm only messing with row 2. So I'm doing 1, negative 1, negative 4. This whole row is going to be divided by 7. So 0 divided by 7 is 0. 7 divided by 7 is 1. And 0 divided by 7 is 0. Okay, I'm almost there. It's looking good. So now you want to get everything else in this column to be a 0. Or in other words, we want this to become a 0. So how can I make this become a 0? So you want this to be the opposite. Well, it's already the opposite. So I just have to do row 2 plus row 1, and we want it to replace row 1. Alright, so let's go ahead and do that. So row 2 is solved for. So we don't want to mess with row 2. Okay, we're going to replace that row 1, so I'm just adding these together. So I'm going to get 0 plus 1 is 1. 1 plus negative 1 is 0. 0 plus negative 4 is negative 4. And now this is in row reduced echelon form. I forgot to write that up here. Row reduced echelon form. And I've solved. So x is negative 4 and y is 0. So this would be negative 4, 0. Okay, this is difficult, like 100%. You have to be careful with adding and subtracting, and there's mental math, like we have to be careful 100%. But you've learned how to do this on the calculator, so we could quickly go check this on the calculator. and confirm, yes, I got this right, or no, I must have made a mistake somewhere. So let's just practice that calculator again. So remember, we go second matrix, second x to the negative 1. Let's go, oh no, we need to go over to edit, and let's move down to C. Again, this was a 2 by 3 matrix. And it was 4, 3, negative 16. And then it was negative 1, 1, 4. Negative 1, 1, 4. Okay, go back to our home screen, second quit. So again, we go second matrix, or second x to the negative 1. We move over to math now. We scroll down to B, R, R, E, F, press enter. We have to tell it which matrix to do, so again we go second matrix, and we choose C. Close the parenthesis, press enter, and we got it right. It's negative 4, 0. Oh, look at that. Alright, so a 2 by 3 is obviously going to be a more simple one than the 3 by 4s. So we're going to probably do 2 3 by 4s. At least one. I'll see how I'm feeling. Okay, so we're going to go ahead and check out a 3 by 4. So this is going to use a lot more of this method, these same concepts, these same things to kind of look for to do a bigger one. So let's go ahead to this one. So this one's actually one that you guys did in your notes with Mr. Till yesterday, or whenever you guys did them. So this is example 1 from notes 3.5, and you did this by elimination, and now we're going to do it by using a matrix. Alright, so step 1 to doing a matrix is put in a matrix. So let's go ahead and put this guy in a matrix. We're going to get 1, negative 1, 1, negative 1, 1, 1, 3, negative 3, 2, negative 1, 2, 0. Just because, like, the way I do my stuff, or the way I do it, like, there's other ways you could do it. Like, you could do a different step at this point, and you could flip rows if you wanted to, maybe where I don't flip rows. There's not just one way to do this. So if you're attempting this on your own, and yours goes a different direction than mine, or a different order than mine, it's no big deal as long as you get the right answer. Okay, so first things first. We want 1, 1, 1, and everything else to be zeros. So again, kitty corner or diagonally, we want the 1s, everything else to be zeros. So we go column by column. We start with our first column. I want this guy right here to be a 1. And lucky for us, this is a 1. So we're good. The next step is we take this one, we manipulate it to make this a 0 and to make this one a 0. I'm gonna do 2 operations at once. Otherwise, this will take us like really long. It'll be really long. So we're totally able to, and we'll just go row by row and we'll discuss it. We'll be fine. So first, let's talk about how to get this to be a 0. Well, I noticed they're already the same number. I just need one of these to be a negative. So what I'm going to do is I'm going to make this row a negative, or an opposite, and then I'm going to add it to row 2. So I'm going to do opposite row 1 plus row 2, and I'm replacing row 2 because I want the 0 here in row 2. Okay, same concept with this guy. I want this to be a 0 as well. So I utilize this 1, I manipulate this 1 to make this become a 0. So I need to multiply this 1 by a negative 2, so then when I add it to this row, this becomes a 0. So we're going to do negative 2 times row 1 plus row 3, and I'm replacing row 3. So again, I'm doing 2 operations in one. If this is confusing, you guys could just do this first one write it out, and then do this second one, write it out. I'm just trying to save space and time, kind of. Alright, so let's draw our next matrix. Okay, so row 2 is going to change. Row 3 is going to change. The only thing not changing is row 1. Copy it down. 1, negative 1, 1, negative 1. Okay, so row 2 is going to change. So what I am doing to change row 2, I'm doing the opposite of row 1 plus row 2. So I'm doing opposite of 1, so I'm doing negative 1 plus 1 is 0. So I write a 0. I'm doing opposite of this negative 1, so I'm doing positive 1 plus 1 gives me 2. This is now going to be a negative 1 plus 3 would give me 2. And this is now going to be a positive 1 plus negative 3, which gives me negative 2. So hopefully you guys all followed that. Alright, now I'm going to do the other one. So now I'm going to take that row 1 and I'm going to multiply it by negative 2 and add it to my third row. So I'm going to do 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. I do negative 2 times negative 1. This is now a positive 2. 2 minus 1, or 2 plus negative 1, will give me a 1. This is going to be negative 2. Negative 2 plus 2 gives me a 0. And then this guy is going to be negative 2 times negative 1 gives me a positive 2. 2 plus 0 is 2. Did I make a mistake? I might have made a mistake. Hold on, let me check while I made it. Let me check if I made a mistake. No, I didn't make a mistake. I was just being silly. Okay, so let's move on. Okay, so looking good. If you guys notice right here, and I'll just point this out. If you guys notice, this is my y value, and it's already solved. Y equals 2. So what I'm going to do next is I'm just going to flip-flop these two rows, and then this is in the right position for row reduced row echelon form. So that's going to be my next move. I'm going to just go ahead and take row 2 and swap it with row 3. Alright. Okay, so row 1, again, not changing. 1, negative 1, 1, negative 1. Row 2, 0, 1, 0, 2. It's already solved. Beautiful. And then the row 3 is now 0, 2, 2, negative 2. Alright. I'm just going to take care, just because I see it and it's going to bother me, and I'm just going to take care of it now. Notice row 3 is now 2, 2, and negative 2, so just to make our lives easier, let's just go ahead and divide out the 2 and simplify that. So let's just do row 3, it's going to get divided by 2, and we're just going to replace row 3. Just to make it prettier. I just notice it, so I'd rather just take care of it. 1, negative 1, 1, negative 1. Do you have to do that? No, definitely not. 0, 1, 0, 2. And I get 0. Dividing all this by 2, I'm going to get a 1, and a negative 1. Perfect. Okay, so now we can move on. Alright, so our first column, good. Second column, we want a 1 to be right here. We have a 1 right there. And then we want to manipulate this 1 to get this to be a 0 and to get this one to be a 0. So notice on this one, I can just add these two rows together and this will give me a 0, so I'm going to do that. Row 2 plus row 1, and we're replacing row 1. Okay, row 2 is good to go. Okay, and then for this one, right, I need this guy to be a negative, so I'm going to do negative row 2 plus row 3, and I'm replacing row 3. Alright, so the only row that's not changing is row 2. 0, 1, 0, 2. And we don't want row 2 to change at all anymore because it's solved. All right, so let's go ahead and do the row 1. So for row 1, we're just doing row 2 plus row 1. So I'm doing 0 plus 1 gives me 1. 1 plus negative 1 gives me 0. 0 plus 1 gives me 1. 2 plus negative 1 gives me 1. All right, good. Bottom one, I'm doing opposite of row 2 plus row 3. So I'm doing negative 0 plus 0 is 0. We're doing negative 1 plus 1 is 0. Again, this is negative 0 plus 1 gives me a 1. And negative 2 plus negative 1 gives me a negative 3. Beautiful. We're almost done. I know what my y is. Y equals 2. I know what my z equals. Z equals negative 3. Last thing I need to solve is I need to get rid of this 1 right here and make it a 0. I have my 1 in this column in its position, so again we utilize this 1 to make this a 0. So, hopefully you're getting the hang of this now. So I'm going to make this a negative 1, add it to row 1, and replace row 1. So negative row 3 plus row 1, replace row 1. That's the only thing that needs to be done. So row 2 is the same, so just copy it. Row 3 is the same, copy it. Row 1 is going to be the one that changes. So again, I'm going to get negative 0 plus 1 is 1. Negative 0 plus 0 is 0. Negative 1 plus 1 is 0. And this is now going to become positive 3 plus 1 is 4. This is in row reduced echelon form. Beautiful. And my answer to this is 4, 2, negative 3. And if you look back to your notes to that example, that's the same example you guys got by doing elimination. I hope that you guys are starting to see some patterns and starting to see some similarities between all these, solving all these matrices. Let's go ahead and do one more. Okay. Last one, this is also from that same set of notes. This is example number 3 though, and I already put it into the matrice. Okay, so looking at this matrice, step 1. So I'm going to go a little bit faster. So step 1, we want a 1 right here. We have our 1. We want everything else to be zeros. So we utilize this 1, make this all zeros. So in order for me to do that, I'm going to multiply 4 times row 1, add it to row 2, and I'm replacing row 2. Okay, this guy right here, I need a negative 2, so I'm going to do negative 2 times row 1, add it to row 3, replace row 3. Okay, the only row that's not changing is row 1, so you can copy it down. And the other 2 will be changing. Okay, so for this one, I'm going to get 4 plus negative 4 is 0. This guy is going to give me a negative 8 plus 1 is negative 7. This will give me a 4 minus 2 is 2. And this guy right here will give me a negative 16, so that's going to give me a negative 15. All right, next I'm going to take that top row, multiply it by negative 2, add it to the bottom row. So I'm going to get negative 2 plus 2 is 0. This is going to give me a positive 4 plus 2 is 6. This is going to give me a negative 2, negative 1 is negative 3. And this will give me a positive 8, and 10 is 18. Perfect. Okay, so next move, we have to be a little smart about this. I need this guy to now be a 1. I don't see a simple way to get this to be a 1, honestly. Like, I can't divide by something in common, nothing like that. Okay? We're gonna get fractions on this one. This will be fun though. But I do notice on row 3, right? Row 3, I could ultimately divide all those by 6s. I will get a fraction, but it's a half. Like it's not gonna be brutal. So what I'm going to do is I'm going to actually swap these two rows, and I'm going to divide this row by 6. So I'm going to take row 3, I'm going to divide it by 6, and I'm going to swap that with my row 2. Alright, so let's go ahead and do that. Okay, row 1 is not changing. 1, negative 2, 1, negative 4. Okay, so row 3 is going to become my row 2, and I'm going to divide by 6 as I do that. So I'm going to get 0 divided by 6 is, I'll keep that in green. 0 divided by 6 is 0. 6 divided by 6 is 1. Negative 3 divided by 6 is negative 1/2. And 18 divided by 6 will give me 3. So again, it's not that bad. Is there a way to do this without fractions? I'm sure there is. This is just the way that my brain sees it, and that's why I go for it. You have to do what makes sense for you. Okay, and then row 2 is now going to become row 3, so we're just going to copy that down. So we get 0, negative 7, 2, negative 15. Perfect. All right, so again, I have my 1 in position. We manipulate the 1 to get rid of these, or to get these to be 0. So I need this 1 to become a 2 to get rid of that one, and I need this 1 to become a 7 to get rid of that one. So next move is I'm going to do 2 times row 2, add it to row 1, replace row 1. And then for this guy, 7 times row 2, add it to row 3, replace row 3. Okay, so what's not changing is your middle row, so that's going to stay the same. So just copy it down. And the other two will be changing. Okay, so we'll do row 1 first. So I'm going to get 2 times 0 plus 1 is not 0, that's 1, is 1. 2 times 1 is 2, 2, and negative 2 give me 0. 2 times negative 1/2, right? The 2's will cancel, so I get a negative 1, and 1 gives me a 0. Look how beautiful that works out. I just solved my top row. And then 2 times 3 is 6. 6 and negative 4 will give me a 2. So we already know x is 2. Okay, bottom row. I'm multiplying this one by 7 and adding it to the bottom. 7 times 0 is 0, plus 0, 0. 7 times 1, 7, negative 7, 0. This one, a little bit more difficult if we need to do that. 7 times negative 1/2, that's negative 7/2, plus 2. Well, 2 is really 4 over 2. When we have common denominators, you just add or subtract the tops. So I'm going to get negative 3 over 2. And this guy right here, we're going to get 7 times 3 is, what, 21. 21 minus 15 would give me a 6. Okay. Making progress. Alright, so my second column's done. Now we're on the third column. First thing to do is get your 1 where you want your 1. So how do we get a fraction to become a 1? We just multiply it by its reciprocal. So I'm just going to take row 3 and multiply it by negative 2/3. And I'm replacing row 3. Okay, row 1 stays the same. We're done manipulating row 1 because it's already solved. Row 2 is going to stay the same for right now. And row 3, I'm going to get 0 times anything is 0, 0 times anything is 0. Negative 3/2 times negative 2/3 would give me a 1. And then if you guys need to, I guess we could do this math over here. And then we have to do this negative 2/3 times 6. Easy one, 3. Those will cancel, so I get a negative 4. All right, we're almost there. Almost there. I need this guy to become a 0, so we use our 1 to manipulate it to become a 0. So I need to multiply this 1 by 1/2, or divide it by 2, however you want to look at it, and then add it to the row. So I'm going to do 1/2 of row 3 plus row 2, and I'm going to replace row 2. All right, so row 1 is staying the same. Row 3 is staying the same. Row 3 is solved, if you guys noticed. And this guy right here is the only one that's going to change. So I'm going to get a half times 0 plus 0 is still 0. A half times 0 plus 1 is still a 1. A half times 1 is a half. A half and negative half gives me a 0. A half times negative 4, or negative 4 divided by 2, is negative 2. Negative 2 plus 3 is 1. This is now in row reduced echelon form. So yay, we did it. And my answer would be 2, 1, negative 4. And if we look back to yesterday's notes or the last notes, this was the answer that you guys got. Okay, I'm sure matrices seem very overwhelming. Hopefully that you're like seeing a pattern. I'm pretty kind of nice. I'm kind of nice, I guess. I usually just give you a 2x3, like the smaller ones, and I expect you to be able to row reduce those smaller ones. All right, that's it for these notes. Save all these extra ones in a safe spot so you can reference them later. Okay, have a great night. Or it's nighttime here. Have a great day or night or whenever you're watching this video.